In this lab, we will familiarize ourselves with digital multimeters. We will also investigate the relationship between the charge and potential difference of a capacitor. Well, we'll use a smaller one. And then we will verify the derived rules for capacitors in series and parallel. We will learn how to use the digital multimeters using 2 batteries and a variable resistor box. When we want to measure the current going through the system, we want to connect our digital multimeter in series with the batteries and the resistor box. You can imagine something in series being like the components of the circuit holding hands.
We are in series.
When we measure the voltage across the resistor, we want to hook it up in parallel. Something connected in parallel would be like the components dancing.
We are in parallel.
We will study the voltage-charge relationship of a capacitor using a charge pump. So we have this set up. When we want to measure our current, we hook it up in series. And to measure the voltage across our capacitor, we can set this up in parallel. In order to charge our capacitor, we push this red button on the charge pump. And we can use a stopwatch on our cell phones so that we can time every 10 seconds or so how the voltage changes. Once it starts to level off, we can make a graph of voltage versus time and use that graph to get the capacitance of our capacitor. Next, we will discharge our capacitor over a resistor. First, I've charged it up real quickly with our batteries. Then, we just unplug, connect to our resistor, and we can once again use a stopwatch to time as the voltage drops. Afterwards, you can make a graph of voltage versus time and figure out the capacitance of our capacitor and also its time constant. Afterwards, we can hook our capacitor up to the Z meter to confirm. Finally, we will use the mahogany terminal blocks to see how capacitors add in parallel and series.